Good afternoon, this is Ms. Biller back, and we're going to talk about prime number factorization. So first we need to know what a prime number is. So a prime number is a whole number greater than 1 that only has two factors, 1 and itself. So 1 is not a prime number because 1 is called the unity number. So many people confuse 1 as a prime number when it is not. So a composite number is a whole number. Remember whole numbers, 0, 1, 2, 3, 4. So a whole number greater than 1, so that excludes 0 and 1. So a whole number greater than 1 that has more than two factors, okay? So that's what makes a composite number. Okay, so a prime number has only two factors, 1 and itself. A composite number has factors that are greater than 1, so more than two factors. Okay, so 6 would be a composite number, because 2 times 3 equals 6, because 2 times 3 equals 6. So that's greater than 1, and it's more than two factors. So 1 times 6 is one factor, and then we have another factor. So this is called a composite number. Okay, and a prime number would be something like 5, where you can only say 5 times 1. So let's determine whether this number, 127, is prime or composite. So again, I'm going to use the factoring tree, which I will teach you about in a later lesson, but it helps me to organize. So first, I see it's not even. So it's not divisible by 2. Then I check, is it divisible by 3? And I add 1 plus 2 is 3. 3 plus 7. 3 plus 7 is is 10, and that is not divisible by 3, so this number is not divisible by 3. So then I look at the next prime number I can think of. So let's write the ones that we've tried. Actually, I may not use a prime factorization tree. So we ruled out 2, not 2, not 3, not 5. So those are our first 3 prime numbers. So 7, will 7 go into that? So 7 going into 127. So we have 17 here, and we subtract, and we have 57. Well, that's not going to work, so 7 is off. Okay, so our next prime number is 11, and I know that that doesn't go into 127, so I don't even need to try. Okay, so how about 13? That's our next prime number. So, so we look at, well, what times 13 ends in a, or what times 3 ends in a 7? So 3 times 9, because we need a 7. So if we multiply 3 times 9, we get 7, carry a 2, and that's 117. So we just missed it, because when we add another 13, we get 130. So it's not 13. Okay, at this point, once we are above 13 times 13, which is 169, we know that that is not divisible by any of the lower primes. So this one is prime. Okay, because once we can square the last one we try and it's bigger than this, we're done trying. Okay. All right, so let's look at 473. So 473, it's not divisible by 2 because it's not even. If we add 4 plus 7, that's 11, plus 3 is 14. 14 is not divisible by 3, so that's out. We look at 5, and it's not ending in a 0 or 5, so that's out. We can try 7. So that would give us 6 and 42. We subtract, and that is out. So 7 is not 1. Okay, so let's try the next prime number, 11. Well, okay, so that would give us 4 here, 44. We subtract. We get, oh, look at that. It's 11. 11 times 43. So this one is 11 times 43. Both of these numbers are prime. So that means that this is a composite number. All right, let's try another one. So we have the process to express a composite number as a product of prime factors only is called prime factorization. Okay, so we're only going to use prime numbers to explain these numbers. Okay, so we're going to factor them just with prime numbers. Okay, so we know that it's not divisible by 2. Okay, we also know, let's see, do we know this? Okay, so it's 5 plus 8 is 13 plus 5 is 18, and that 18 is divisible by 3. So we can divide by 3, and we get, there's 1, 3, and 5, carry a 2, there's 9 3s and 28, carry a 1, and there's 5 3s and 15. So we add them together again. 1 plus 9 is 10. 5 is 15. That is divisible by 3 again. So 3 into 19 is 18 is the first one. So that would be with 18 is a 6. Carry a 1. And then we have a 5 for 3 times 5 goes into 15. All right, so now let's try that again. 6 plus 5 is 11, not divisible by 3 anymore, but it is divisible by 5 because it ends in a 5. So that gives us 1, 3. And now we have all primes. All right, let's go look at this one. It's not divisible by 2 because it's not even. 2, 4, 6, 8. Or 0, so we're not seeing one of those. So let's add 2 plus 7 is 9, plus 3 is 12, so that's divisible by 3. So we can take a 3 out, and that gives us 91. Now 9 plus 1 is not divisible by 3. This is not divisible by 5 because it doesn't end in a 0 or 5. 7 does not go into, or maybe 7 does. Let's try that. So we can take 1 7 in here, subtract. We get, oh, look at that. It did. So we can take a 7 out of this, and we get 13 left over. Very nice. So those are our prime factors of 273. All right, if we want to prime factorize this one, we see it ends in a 0, so it's even, so we can take a 2 out. When we do that, we end up with 8 with 1 left over, 85. So it's no longer even. If we add 8 plus 5, that's 13. So that is not divisible by 3, but it ends in a 5. So it is divisible by 5. So let's see what we get. So there's 1, 5, and 8, carry a 3, and there are 7 5s in 35. So this is how this one will prime factorize. So these are called prime factorization trees. So prime factorization trees. Okay, so they're very, very helpful. I like them quite a lot. All right, so let's talk about exponential notation. So if I have 7 times 7 times 7, those are 3 7s multiplying each other, I can write 7 cubed. Okay, you can also write 7 to the third, but in math we say 7 cubed. So 8 times 8 times 8 times 8, so there's 4 of these 8s. So we would write 8 to the fourth. Okay, a times a, that would be a squared. So a squared. You could say a to the second, but in mathematics we say a squared. And b times b times b, that would be b cubed, because there's 3 b's multiplying. C times c times c times c gives us 4 of these c's, so c to the fourth. And d times d times d times d times d is 5 of them. So it'd be d to the fifth. So in general, a squared does not equal 2a, because a squared is a times a, versus 2a is a plus a. B cubed does not equal 3b, because b cubed is b times b times b. And that doesn't equal, in general, b plus b plus b, unless everything's a 0. So let's look at how we prime factorize 702 and then write it in exponential notation. So let's take 702 and start taking it apart. So it's even, so we can take a 2 out. When we divide that by 2, there's 3 2s in 7, carry a 1, 5 2s in 10, and 1 2 left over, or 1 2 and 2. So let's add them up. 3 plus 5 plus 1 is 9. That is divisible by 3. It is not even, so it's not divisible by 2 anymore, but it is divisible by 3. So there's 1 3 and 3, 1 3 and 5, and there's 7 3s in 21. So again, we add them up. 1 plus 1 plus 7 is 9. That's divisible by 3. So there are 3 3s in 11 with 2 left over, and there's 9 3s in 27. And we check. 3 plus 9 is 12. 12 is divisible by 3, so this is divisible by 3. So there's 1 3 and 3, and 3 3s and 9. So now we have all the prime factorization done. So if we want to write this in exponential notation, we start from least and go to the greatest, and we have 2 times 3, but we have a lot of 3s. We have 1 2 3. So we write a 3 up here, and then times 13. And that is exponential notation. So exponential notation is this. So let's prime factorize these and put them into exponential notation. So this is even, so we're going to take a 2 out. We take a 2 out, we get 90. It's still even, so we take another 2 out, and that gives us 45. Okay, it's 4 plus 5 is 9, so that makes it divisible by 3. So we have 1, 5. 1 plus 5 is 6, it's divisible by 3, and then we have 5. So this is prime factorized, and that equals 180. So we would write this as, let's see, we'd write this as 2, and there's 2 of them, squared times 3 squared times, and there's a 5. So this would be the exponential notation. There's 2 2's, there's 2 3's, so 3 squared. So 2 squared times 3 squared times 5 is the same thing as 180. Let's see what 616 shows us. So it's definitely even and divisible by 2. So there are 3 2's in 6, 0 in 1, and there are 3 2's in 6 again. So 3 plus 3 is 6. It's divisible. It's by 3, and that's not even anymore, so we're going to divide by 3. So that gives us 101. 1 plus 1 is 2. That's not divisible by 2, or 3. It's not divisible by 5 because it's not ending in a 5 or a 0. So if we try 7, 7 does not go into 101. 11 does not go into 101. So let's try 13. So we want 13, and we want it to end in a 1. We know 7 times 3 is 21, so that ends in a 1, but that's 91, so we just missed it. Okay, so let's try the next prime number up is 17. So 17 times 3 won't do it. We have to end in a 1. So that's 5, 6, 8. Nope. So that's not going to work. And so 101 is prime. Okay, because we went way over, because 13 squared is 169. So we tried 13, it didn't work, so that is prime. So the prime factorization of this is just 2 times 3 times 101. And there's no exponent. And that is it for this lesson. So have a wonderful day.